The first in a series of events hosted by the members of the Alliance of International Scientific Organizations, ANSO, we call it shortly ANSO. At the third ANSO governing board meeting in November of the last year, the Russian Academy of Sciences proposed holding a series of online meetings on various globally significant and prominent scientific topics. Among them is public health and food safety, agriculture, biodiversity, fundamental science and higher education, ecology and green technology, innovation and technology transfer. The first in this series of events will be held on climate change and its impact on our planet and our livelihood. And I would like to thank you all for joining us at this memorable event. The theme of the first day of the event will be climate change in hot spot areas. Today we will have the chance to hear a presentation by some of the world's most prominent experts in the area of climate change. We also have an honor of being joined for the opening session by Dr. Jian Liu, United Nations Environment Chief Scientist and Director of the Science Division, Professor Jörg Lutherbacher, Director of the Science and Innovation Department of the World Meteorological Organization, and Professor Bai-Chun Li, the President of ANSO. But first, please welcome President of the Russian Academy of Sciences, Academician Alexander Sergeyev, to say his opening remarks, and welcome you all right after we watch a very short video profile. Please.
Dear Professor Bai-Chun Li, dear colleagues, we are launching today a series of our online seminars dedicated to the most important problems of scientific and technological development of our international community. And we know that our Alliance of International Science Organization is committed to promoting sustainable development in different areas of our socio-economical and technological life. And we discussed different opportunities during our general assemblies and general board meetings several times. In November 2020, when we met for our governing board meeting, we decided to initiate a new series of our discussions, our online meetings or our webinars, dedicated to several topics of our joint research. They are climate change and its impact, public health and food safety, agriculture, biodiversity, fundamental science and higher education, ecology and green technology, innovation and technical transfer. And today we start with our first webinar, which is about climate change and its impact. We all know that our planet faces very difficult challenge due to the climate change. Glacier melting, sea level rising, extreme weather event, they all becoming normal, unfortunately, normal event in our world. There are both anthropogenic and natural geodynamical reasons for that. But it all affects natural environment, socio-economical and human livelihood. Climate change is the most crucial common challenge for all countries and for all humanity. And there were several efforts, such as Paris Agreement and United Nations Sustainable Development Goals, so that our current situation is so that we certainly have to implement, we start to implement ideas of these agreements to reality. And today we know that we are living under new paradigms such as carbon neutrality, green energy, green chemistry, and so on. And all this should be discussed during this session. I have also to add that meanwhile, we see that COVID-19 makes things around the problems we are discussing more complicated, as it's resulting change in individual behavior and social attitudes, which will have long-term effects on climate change. In our session, Climate Change and Its Impact, we will discuss different aspects of climate change, from shifting weather extremes to disaster and food security, from glacier permafrost melting to water supply and livelihood, from biodiversity change to ecosystem services, from national mitigation adaptation strategies to international cooperation, etc. This session is designed to discuss the research challenges and solutions of climate change, evidences, drivers, impacts, and interactions between natural and social systems. This session includes keynote talks and panel discussion with respect to frontier research and recent developments. And I wish all participants interesting discussions on these topics and successful start of our ANSO online topical meetings. Thank you.
Dear colleagues, now I would like to welcome President of ANSO and the Commissioner of Chinese Academy of Sciences, Professor Baijun Li. Please first we'll watch a short video profile.
Thank you, Chairman. Dear President Sergey, fellow ANSO members, ladies and gentlemen. So first of all, a big welcome to you all to the workshop on climate change and its impact under the ANSO online open conference on behalf of the ANSO. I want to particularly thank President Sergeyev of the Russian Academy of Sciences for the leadership and the coordination of this meeting. My thanks also go to our ANSO members and other cooperative partners for their efforts and support. I'm very pleased to note here that ANSO continued to develop forward last year in spite of challenges and difficulties caused by COVID-19. In the last 2 years, we got 20-some applications to join ANSO, which were endorsed by the ANSO governing board. ANSO did a good job in launch and the implementation of a number of initiatives planned, including the recruitment of the 300 PhDs and 200 master's students to study in China. The kickoff supporting of the first group of internationally called projects, the joint organization of the large number of online international activities with other organizations, including UN Conference on Trade and Development, and the further enhancement of the voice and the impact of ANSO by expanded efforts in public media, and the dissemination of the science progress on COVID-19. I want to particularly emphasize the big role that ANSO played in the joint fight against COVID-19. For example, it was due to the efforts of the ANSO Secretariat that the third phase clinical trial of the recombinant protein vaccine developed by China was successfully accomplished in Uzbekistan, which led to its emergency use authorization in Uzbekistan, further promoting it to be approved for EUA in China. Just centering on bringing the third phase clinical trial of the vaccine, the ANSO Secretariat bridged and assisted the organization of no less than 30 international webinars. It was also due to the role played by ANSO that some international efforts have been ongoing in the joint development of testing kits and the drug against COVID-19. To make a long story short, the ANSO stories of the joint fight against the pandemic in 2020 truly demonstrate the power and the impact of the unity, togetherness, and the partnerships of the ANSO family. Today's workshop on climate change is one of the 7 or 8 ANSO online meetings scheduled to come in 2021. At the last November's governing board meeting, all board members agreed we should organize a series of workshops focused on major human concerns and challenges in 2021. Climate change ranks among the top. The reason is crystal clear. Climate change poses the biggest challenge and threats to global sustainable development as it brings more uncertainties, new risks, and new changes to the existing Earth system. It also relates to the outbreaks of the infectious diseases. 2020 recorded a number of the historical highs in the climate-caused disasters and extreme weather, such as the big flooding, bushfire, ice loss, and locust outbreaks. Several regional events are also record-breaking, such as the sudden mass glacial burst in the India Himalaya region, and catastrophic winter storm that hit the central and southern parts of the United States. All these extreme events and weather caused both huge human lives and property loss and damage. It is clear enough if we humankind to not act now and in a forceful way, we are likely to face an even more challenging future. ANSO, as an international science organization with the vision to advance green and sustainable development, is committed to playing a dual role in tackling the climate change challenges. I'm pleased to see that ANSO programs and activities very much center on eco-environment and sustainable issues. As the ANSO Secretariat is located in China, please allow me to briefly touch on the Chinese policy on climate change. China is very much committed to tackling climate change and holds that only through multilateralism, unity, and cooperation can humankind tackle the challenge effectively. China is adopting vigorous policies and measures for greener economic and social development. It aims to peak its carbon dioxide emissions before 2030 and achieve carbon neutrality by 2060. To meet this set policy, significant amount of the work will have to be done, including to lower carbon dioxide emissions per unit of the GDP by over 65% from 2005 level, increase the share of the non-fossil fuels in primary energy consumption to around 25%, plant more trees and install more capacity of the wind and solar power. As for the international scientific community, I shall say we need to further enhance the voice of the science and give more efforts on science-based policy and actions. We shall carry out unified actions in the following. First, to provide more solid science on climate change for better looking after our Earth. Second, to strengthen basic research for sustainable development. That's to provide shared and quality data for advancing the UN SDGs set on climate change. Third, to research and develop cutting-edge technologies towards carbon neutrality, especially clean and renewable energy, geoengineering, and carbon budget monitoring, and to make them available in the framework of the IPCC shared social economic pathways. This meeting today is such a good platform for us to share and discuss all these important issues. With the above, I want to conclude by thanking you all for your support to the meeting and wish you all a very good meeting. Thank you very much.
Thank you very much, Academician Bai-Chun Li. Now I would like to invite the United Nations Environment Chief Scientist and Director of the Science Division, Dr. Zhan Lu, to say a few words of greetings. Right after we watch a short profile video, please.
Thank you very much, Professor. Good morning, good afternoon, good evening, all participants. Your Excellency, President Sergey, Your Excellency, President Bai Chunli, academicians, excellencies, ladies and gentlemen. It is great honor for me to join this conversation today. I think this is the right topic for the ANSO, and this is the right time to start this conversation to sort of mainstream this topic on climate change in the ANSO research activities and discussions. I would like to also mention that on the 18th of February, the Secretary General of the United Nations, Mr. Guterres, launched our synthesis report of the global assessments in the title, Making Peace with Nature, and he called for actions on climate change, on biodiversity loss, on pollution control. And basically, he wants the whole world to transform our society and economy towards a climate-friendly society and economy, so that we could avoid the sort of risks that we have never seen before. This is something that I would like to introduce to encourage you to see it on the website. It's almost everywhere. And with that, I would like to say a few words on the sort of science and policy interface in terms of climate change, and especially with respect to this discussion, mainly focusing on climate change impact, risks, and adaptation. Let me start with one of the key findings of our adaptation gap report 2020, which is also on the website, is the UNEP Adaptation Gap Report 2020. So basically, this report identifies climate action is not widely embedded in policy and planning across the world. However, finance needed to implement these plans is not growing fast enough. Actually, 72% of the countries have adopted at least one national level adaptation planning instrument, while a further 9% are in the process of developing one, and that is already more than 80%. So most developing countries are preparing for national adaptation plans. But the annual adaptation costs in developing countries alone are currently estimated at 70 billion US dollars, the whole world, the whole developing world. Of course, it is expected to increase by 2030 and 2050. And also the proportion for climate change adaptation and related work in the multilateral development funds only accounts for less than 15%. And I would like to ask the question, why? Because if you look at the climate change convention, the sort of UNFCCC, the science for mitigation is clear. And IPCC provided 2 degrees Celsius as the target not to go above 2 degrees Celsius before the end of the century, prior to industrial revolution. And that's clear. And the mitigation is also sort of what I call technology intensive. But adaptation is different. Adaptation is knowledge intensive. It's quite complex than mitigation, the topic of mitigation. So just to give you one example, how we can differentiate climate variability from climate change. And that's a key topic actually between the developing and developed countries in the multilateral funds, because people will say, well, this disaster is caused by climate variability, the other one is caused by climate change. So So I'm calling researchers for this meeting to try to give developing countries, the most vulnerable countries, something to plan, to argue that more investment adaptation is needed. So the differentiation between climate variability and climate change is the key, right? And also, I realized that this meeting will address some of the hot areas for adaptation. Actually, as you know, the IPCC Force Assessment published in 2007 was the one mostly quoted in terms of climate change adaptation research and policy setting. But those hotspots were already identified, including the sort of frozen grounds, the so-called cryosphere, the cryosphere permafrost, snow and ice-covered areas. And those areas are one of the most vulnerable areas. According to recent studies, most of the research topics on agriculture, water resources, disaster risk reduction, but much less on sort of climate resilient infrastructure. And this is much needed if you talk about sustainable development in those, high altitude and high latitude regions, the Arctic, the Hindu Kush Himalaya region, the Andes region. So these are critically important for those communities and countries. So climate resilient infrastructure, if you talk about solutions, could be one of the research topics that we need to focus on. The other hidden sort of a topic, or I would say crisis, is the peatland research. The peatland in those, peri-Arctic region, in the high mountain region, is a kind of time bomb in terms not only of disasters and things like that, but in terms of the explosion of the greenhouse gases when it is decomposed due to temperature increase, due to the melting of the frozen ground, then it will become a time bomb for greenhouse gases. Of course, there are also adaptation issues in terms of nature conservation and so on. So I could continue, but time-wise, let me just finally congratulate the opening of this conference, and UNEP is ready to support in any way we can. And thank you very much indeed. Thank you.
Sorry again for these delays. Thank you very much, Dr. Liu, for your words of greeting and also for your support of our today's meeting. Okay, next I would like to invite Director of the Science and Innovation Department of the World Meteorological Organization, Professor Lutherbacher, to give his opening remarks after we watch a short profile video. Please.
Thank you very much, Professor Balega, for the introduction. Dear Excellencies, dear distinguished guests, dear academicians, dear colleagues, in the name of the World Meteorological Organization, I'm very happy to welcome you to the Third International Science Forum on the Belt and Road Initiative. The World Meteorological Organization is the UN system authoritative voice on the state and behavior of the Earth's atmosphere, its interaction with the land and oceans, the weather, climate, and the resulting distribution of water resources. Over the past decades, the Belt and Road region have experienced strong warming, that is mainly due to anthropogenic activities. The last decades were the warmest and most likely for more than centuries. And this recent temperature increase is associated with more frequent and more intensive heat waves, droughts, floods, and stronger melting of glaciers, ice caps, as well as changes in the ecosystem. Professor Sergev, Professor Dai, and also Professor Liu already talked about a few aspects of those. On top of that, as we heard also in the introductory speech, is the COVID case. WMO will publish soon the first report on the meteorological and air quality factors affecting the COVID-19 pandemic, which I think is a first milestone in understanding the interrelation between those aspects, and I'm very happy to share with you at a later stage. Climate models clearly show that the temperature will increase also in the future, and this acceleration is much stronger across the belt and road region. The changes are larger than at the global scale, which makes the region even more vulnerable with strong impacts and challenges for society, economy, and the nature. And I fully agree with my previous speakers, we need to act. And to reach the Paris Agreement targets, emission reductions in CO2 and other greenhouse gases need to start as soon as possible. National mitigation efforts need to be adjusted and also strengthened. An important step is the 2023 Global Stockdale and preparation of new nationally determined contributions beyond the 2030 period. In collaboration with other United Nations agencies and national meteorological and hydrological services, the World Meteorological Organization supports the implementation of a number of environmental conventions and provides advice and assessment to governments. These activities contribute towards ensuring the sustainable development goals and the well-being of nations. As Professor Liu mentioned in his talk, we need more joint efforts to achieve this aim, and also we need more financial support to actually achieve those. The Alliance of International Science Organizations and organizations developed an exciting program these 2 days with distinguished speakers on very important and hot topics. Different talks during this meeting will address climate change issues on hotspot areas. They address biodiversity, ecosystem responses, the natural hazards and food security across the belt and road regions, but also public health in the post-pandemic period, as well as policies on climate change mitigation and adaptation, and of course, the importance and relevance of future international cooperation. I'm very much looking forward to this exciting meeting and would like very much to thank the organizers to invite me, and please count WMO as very interested and support of this initiative. And thanks very much to be involved in any of these ATES activities. Thank you very much, and back to the chair, Professor Balega.
Okay, thank you very much, Professor Luthebacher, and thank you for joining our event today. Now we slowly move to key presentation of today's session, today's event. Before starting the first talk, I would like to ask the speakers to speak not too fast, because we are translating here some of the talks into Russian. So please note, keep this in mind, that your talks must be not very fast. Now, first of all, I would like to invite Professor Tangdun Yao, Honorary Director and Professor of the Institute of Tibetan Plateau Research of the Chinese Academy of Sciences, to give a presentation on the topic, Third Pole Environment Change. Professor Yao, we welcome you to begin your presentation after we watch your profile video. Please.
Dear Professor Lei, dear Professor Sadi, dear Professor Liu, and dear Professor Lutenbach, dear colleagues, it's my pleasure to talk about the environment change in the third pole region. Actually, my topic today specifically focuses on the Asian Watt Tower changes in the warming climate. Of course, the place we're talking about is basically the Tibetan Plateau and its surroundings. This region also called the third pole. It covers 5 million square kilometers in area with elevation higher than 4,000 meters by average. Its behavior impacts more than 2 billion people. This region is the largest glacial mass covered region, and also the origin of the more than 10 major Asian rivers. So it's widely acknowledged as Asian water towers. Actually, this concept of the Asian water tower was proposed by Netherlands scientist called Walter Imazil, and his famous paper published in Science several years ago. Of course, the changes in the Asian water tower of the third pole region, the major focus is temperature. So we used a lot of different ice cores to recover the climate change in the past 2,000 years. So this is a composite curve of the temperature change in the past 2,000 years based on ice core records. So you can find that the warmest part in the past 2,000 years is the past 100 years, from around 1900 to 21st century. Of course, warmest part in the past 100 years or so is starting from late 1980s. Another very significant characteristic is magnitude increase of temperature increase with elevation. That means that the higher the elevation, the larger the magnitude of temperature increase. So that's why this region is one of the last temperature increase region in the past several decades compared to the global average. Because the global average temperature increase in the past several decades is around 0.19 degrees C per decade. But in this region, it's more close to 0.4 degrees C per decade. If we use the Paris Agreement scenarios with the 2 degrees C assessment, in the third pole region, it will be about 4 degrees C. Of course, that ranges from 3 something to more than 4 something degrees C. Another important feature in this region is interaction between the Indian monsoon and the westerlies. So the southern part is the Indian monsoon influenced the region, and the northern part is westerly influenced the region. So these two atmospheric circulations actually is kind of battle. Cold period, the westerlies will move southward. Warming period, the Asian monsoon moves northward. At this moment, this region characterized with the two different precipitation patterns. In the northern part, it's characterized with decreasing precipitation. And no, sorry. So northern part is increasing precipitation, but the southern part is characterized with a decreasing precipitation. So the whole pattern of the region is especially characterized by the decreasing precipitation pattern in the southeastern Tibet Plateau, particularly along the Himalayas. So that kind of characteristic results in the very intensive glacial melting in the southern part of the third pole region or the Asian Water Towers. But in the northern part, it's some region actually still characterized with the positive mass balance. For example, Karakoram. So some scientists call that as Karakoram anomaly. So these are the photos characterize different retreating patterns in different regions of the Asian water towers. This is a picture series from the Ada Glacier in the southeastern Tibetan Plateau. Called the first photo was taken in 1933, and the recent one was 2006. You see the huge decrease or disappearance of ice from the first photo to the very recent photo. And if you go further to interior of the plateau, you will see reduced magnitude of retreating. And these are the two photos from 1981 to 2006. So the retreating is not so significant. So if you go further to the interior, then the glacial status are rather stable. So this kind of retreating of ice or melting of ice now cause different water processes like lake. So lake levels are increasing in the northern Tibetan Plateau. Lake area is also increasing in northern Tibetan Plateau, but decreasing in the southern Tibetan Plateau. Also lake volume, water volume increases in northern Tibetan Plateau and decreases in the southern Tibetan Plateau. So this kind of ice melting and water process is causing a lot of hazards, like glacial lake outburst is called Gulf, and also very recent new disaster is ice collapse. So the major disasters are characterized by ice melting, by Gulf, and on the northern Tibetan Plateau by glacial lake flooding, because many lakes are expanding. It's flooding pastures of local people. So you may have heard very recently about the ice collapse. Different people call that different names. Some call the ice avalanche. Some people are called the ice collapse. Maybe some people calling other names, but these are formally published papers called that the ice collapse. So the very recent one, very first one was in 2016. The two glaciers collapsed, and these two collapses actually buried the pastures, and then another ice collapse happened in 2018 in the southeastern Tibetan Plateau, and that ice collapse dammed the Yangtze River. And after the first ice collapse, because the ice collapse buried local people, about 10 people and several hundred livestock buried underneath the ice collapse. So local government tried to rescue the people, but there's no hope. And also the ice collapse in 2018, the dam, the river, and destroyed the bridge, destroyed the roads, and also local people had to move to other places, and now there's no hope to come back. So that's why Nature had a special report called this kind of disaster as deadly disaster. And the glacial lake expansion is especially kind of a special disaster process in the northern Tibetan Plateau, because the local people live around the lake where the best pastures exist. So now they have to move from the pastures. So scientists spend a lot of effort to study what the process are and what will be a potential risk. And what we found is that the warming and wetting accelerate the melting in Ashwa towers, and consequently result in its imbalance, which gives rise to new and greater catastrophes with serious social consequences. And we also found that the Earth system response induced by third pole climate change have led to new and great catastrophes in Ashwa towers. And we also found the impact of Tibetan Plateau's low atmospheric circulation in East Asia will be another potential risk in the future. This is only for the third pole region, but its impact is not limited to the third pole region. It's in the northern margin is so-called Great Lakes region in Central Asia. In the southern margin is so-called Great Rivers region in Southeast Asia or South Asia. So the impact is regional, and some people think it's even global. So regional speaker, of course, we know the biggest lake, Aral Sea in Central Asia. It was more than 60,000 square kilometers in 1960s, but now it's about 3,000 square kilometers or so. So that's why the Secretary General of UN visited this place in 2017 and warned that the Aral Sea's progressive disappearance is probably the biggest ecological catastrophe of our time. We should take action on this issue. And the attention is not only by UN, but from all the political leaders from different countries. The China President Xi Jinping emphasized the importance of making strategy of protecting Asian water towers. And former President of Iceland, he visited this place several times. He's organizing the Arctic and third pole programs together to use the Arctic protecting experience available for the third pole region. And the former Vice President of US, Al Gore, also paid special attention to the climate change in this region. And of course, we have very close collaboration with UNEP, particularly Professor Jia Liu. And we had agreement to push forward the environment protection for the third pole region or pan-third pole region. So now we actually focus on some special urgent issues in this region. Firstly, quantitative understanding of how much water each water tower has stored, and quantitative understanding of different water vapor transportation process in the overall water budget. Water phases conversion between solid, liquid, vapor phases affecting regional hydrology. Physical processes that affect glaciers, including impacting of aerosols, surface debris on ice, accumulation, and melting. And finally, to integrate the observation models to predict the future fate of the Asian water towers in a warming climate. So the nature had a special focus on the third pole environment. This is what published by Nature several years ago, special figure for the third pole. And several senior scientists who have been working in this region for a long time, like Lonnie Thompson from US, Volker Moosbrugger from Germany, are interested to have a kind of international program to emphasize the studies in this region. So that's why we had a third pole environment program called TPE, initiated in 2009, and which was later on a UNESCO flagship program in 2011. And with the progress of the program, we had some key scientists from different countries involved in the studies, including scientists from Sweden, from France, from Netherlands, from Great Britain, from Norway. And with the progress of the TPE, we also now take a special program focused on third pole region environment program. So this program focuses on water ecosystem, human activities, particularly on the changing Edgewater Tower and the impacts beyond the third pole, and on adaptation strategy with the involvement of scientists and policymakers. And 2 years ago, we launched another program focused on third pole environment change, particularly on the Tibetan Plateau. We call that STAPE, and Second Tibetan Plateau Scientific Expedition Research. We have 10 projects in this program, including westerly monsoon interaction and its impact, Asian water tower changes and their impacts, ecosystems security, ecological buffer capacity and its optimization, biodiversity conservation and sustainable use, anthropogenic impacts and environment security, plateau uplift and evolution, resources and energy assessment, environmental disaster, green development pathways. So the basic approaches we are using for this kind of programs or projects are based on the stations we already established, including stations on the Tibetan Plateau in the Central Asia countries and also the South Asian countries. And we are also cooperating with companies or institutions of Chinese Canadian sciences, developing new technology. This is what we are developing now, using for observation from space to the surface. This balloon can go high in the air about 10 kilometers above the Tibetan Plateau. So the water transportation, and the aerosols and black carbon processes can be observed by this new technology. And also developing international networks for the third pole and the para-third pole environmental studies. We have centers established, including the para-third pole region, US, Sweden, Germany, and some other countries in the future. And we had a special agreement signed with UNEP and the WMO. WMO actually take TPE or third pole environment as a partnership to cooperate with the new program focused on the interaction of climate, cryosphere, and hydrosphere in the future. So we are looking forward for further cooperation with more scientists worldwide to address challenges of ocean water table changes in a warming climate and to protect our future sustainability. Thank you very much.
Thank you very much, Professor Yao. I'm sure there are many questions and will be more questions in the future, but please write them in comments or save them for the end of the session. And in the end of the session, we'll have a discussion. Okay, thank you very much again. Now I'd like to invite the Vice President of the Russian Academy of Sciences, academician Andrei Adrianov, to present on the impact of climate changes to marine ecosystems in the Russian Far Eastern seas. Please, Andrei Vladimirovich, please, after the short video profile, you can talk.
Thank you, Mr. Chairman. Dear colleagues, global warming is a real challenge to the sustainable development of humankind. Some of the effects of climate changes are dramatic decrease in the Arctic cover, glacier melting, rising of sea level, extreme weather events in the ocean, global increase of seawater surface, acidification of the ocean, changes in biodiversity and natural ecosystems. On this map, you can see the average change of boundary of ice in the Arctic Ocean. Red and blue lines indicate a boundary of this ice within a few decades. And red arrow indicates a position of Wrangel and Gerald Island in the Chukchi Sea. In 2016, during our marine expeditions, we were not able to find any ice around these islands in September and October. This area is a so-called maternity home for polar bears. And as we saw in this expedition, many polar bears were sitting at rocky shore in deep melancholy. They are not able for hunting. They just swimming around the islands, and they were very short of time to get enough fed before winter time. I will speak mainly about the Russian Far Eastern Seas in the Northwest Pacific. This area is very important for our economy because up to 80% of fish and seafood in our country are caught in this water area. It's a huge water area, more than 5 million square kilometers. In the Russian Far East, the process of the so-called global warming in terrestrial environments is less pronounced than, for instance, in the Arctic region, even as compared with the European part of Russia. But much different situation in the sea. The global warming in marine ecosystem in the Russian Far East, this appears to be much more pronounced than even in the Arctic Ocean. You see changes of average annual temperature of surface water from 1982 to 26. You see that these changes in the Sea of Japan, for instance, are more than 1 Celsius degree. It's a very high temperature for the sea. Global climate changes increase the effect of regional and local climate factors, which results in the mosaic pattern of temperature fluctuation. At regional level, it's very good illustrated in the Sea of Japan. We observed intensification of both warm water and cold water currents in this area. You see the blue cycle indicate Peter the Great Bay, and it's very interesting to consider the mosaic fluctuation at local level using this example. According to the meteorological data, over the last 60 years, the average temperature of surface water in the Peter the Great Bay has increased by almost 0.6 Celsius degree. These changes cause a reduction in the optimal temperature regime of the most valuable cold water species and force them to migrate for spawning to the north. There is a northward displacement of main centers of reproduction of Far Eastern salmons, which move to north from the Sea of Japan and Sakhalin Island. There has been a change in the abundant status of the major commercial fish species. At the same time, there is a northward migration, not only individual species, but also complexes of species of southern biota. Substantial changes occur in the ratio of native fish species to migrant species. Distinct climate changes can be reliably described mainly at the local level. You see a very mosaic pattern of temperature fluctuation in the Peter the Great Bay. In the center part of this bay, we have average temperature change up to 1 Celsius degree, plus 1 Celsius degree. At the same time, in the east part of this bay, we can see minus 0.3 Celsius degree within the last 50 years. You see a satellite image of this water area, and we can see intensification of both warm water current and cold water current to this area. What are main impact of climate changes to marine ecosystem at regional and local levels? First of all, changes in biodiversity and shallow water landscapes, depletion of fish stocks in some areas due to regional and local climate changes, biological invasions, transfer with ballast water, appearance of biofouling organisms, appearance of new dangerous species, problem of toxicological safety of marine areas and seafood because of harmful algae blooms. In the Russian part of Sea of Japan, we have 367 species of fish. exactly 1/3 of them, more than 100 species, are designated now as southern migrants. So the species appear in our water area in summertime with warm water masses and disappear in wintertime. Every year we get more and more new species in this water area. For instance, within the last 30 years, we have about 20 tropical species in our water areas. Many dangerous species appear. For instance, sharks. Sharks are pretty common for the Peter the Great Bay. We have about 20 species of sharks. But because of the very high water temperature in 2011, many dangerous sharks enter our water area, not only for hunting to spotted seals, as usually, but also for reproduction. And our sailors catch them just newborn babies of white sharks, for instance. Unfortunately, these sharks perish. Also, we had at this time some shark attack that never happened before, because of a very high temperature, sharks are much more active and aggressive. We also have many other species of southern migrants, like sea turtles, snakes, and huge jellyfishes, and also many tropical species like this very beautiful bistabranch mollusks, which now arrange stable populations in our water area. About 66 introduced species have been already recorded for Russian Far East, and 56 species identified in the Peter the Great Bay are non-indigenous. 17 of them are new fouling species. I should say that within the last 30 years, the average biomass of fouling organisms per 1 square meter of hydrotechnical constructions in the Peter the Great Bay has increased from 2 up to 20 kilo because of very large biofouling tunicates like Mongula manhattanensis or Selona savigny. This is a very interesting experiment. You know, there is a so-called international rapid assessment of alien species. So taxonomists put together and jump to any monitoring area and collect as many as possible species and identify them to a species level and compare with the previous checklists. In 2011, we arranged this rapid assessment in the Peter the Great Bay and find a very interesting fact. We found 100 species of crustaceans, amphipods. That's okay. And compare with a checklist of the same taxa 30 years ago, 20 years ago, collected in 1984. The species were identified by the same taxonomists. The same taxonomists in 1984, the same taxonomists in 2011. And only 9 species present in both lists. What it means? First impression, the situation with biodiversity is okay. Biodiversity is very high, but actually, one species complexes have been replaced by another species complexes. And this fact can be identified only by taxonomists. Absolutely the same situation with hermit crabs. Within the last few decades, we got very intensive harmful algae blooms in the Russian Far East. For instance, harmful algae blooms in 1980, 2005 is up to 5 times more frequent as compared with a period of time in 1970s, in 1980s. And salinity and temperature are known to be key factors to determine the chemical toxin profiles of microalgae. It's logical to expect toxin modification with climate change. You see the algal blooms directly in the city of Vladivostok, the capital of the Russian Far East. And it never happened in winter time before. 3 months ago, in December, for the first time, we got very intensive bloom of Noctiluca scintillans in December. Moreover, in 2019, we got a very intensive under ice bloom of Noctiluca scintillans in the vicinity of Vladivostok. Some much more dangerous microalgae species also provide more intensive and widespread harmful algae blooms. On this picture, you can see many dead walruses in Kamchatka, Chukotka, and Wrangel Island. For instance, the number of these mammals decreased from 15 to 5,000 individuals in the very short period of time, 2003, 2004, without any walrus hunting, but just because of poisoning by toxins produced by microalgae. Maybe you know the story last autumn in Kamchatka water area. Because of extremely high water temperature in September and October, we got extremely intensive harmful algae bloom alongside both east and west coastline of Kamchatka because of bloom of Carenia species. And it's a Carenia species, a very high concentration of toxins in water cause mass die-off many bottom species of invertebrates and bottom fish. What to do in this situation? First of all, joined our efforts in inventory of marine biodiversity and in monitoring of bottom landscapes and coastal ecosystem under climate changes in the Northwest Pacific. To develop international cooperation in environmental transboundary problems, including harmful algal blooms and macroalgae diversity, monitoring of biological invasions and transboundary transfer of dangerous species, cooperation in toxicological safety and control of food chains, and cooperation of taxonomists in rapid assessment of biodiversity changes in coastal localities. Thank you.
Thank you very much, Academician Adriano. The next presentation is from Professor Chun Xia from the School of Water Resources and Hydropower Engineering of Hunan University and the Chinese Academy of Sciences. Professor Xia, please begin after a short video profile.
Thanks, Chairman. Good day, the distinguished guests, the ladies, the gentlemen. In my presentation, I'd like to address the water security issue for large river basin, but I gave the case study in the Yangtze River in China. So in my presentation, I like to address the 3 points. First is about the water security issue in the Yangtze River. You can see this some of the tables. The Yangtze River is the largest river in China. It has played a key role on social and economic development in this country because both the freshwater food production occupy the 1/3. Also, the population, the GDP occupy the 14% in China. But however, it's face big challenge on changing environment, particularly for climate change, also land use coverage change. Today, our topic that focus on the climate change impact and adaptation, because Professor Tan Dong Yao is already, gave the presentation about the 3rd pole includes the upstream, the Yangtze River. But I like to say the air temperature is rising, which resulted in the degradation of the frozen soil layer in the upstream. It's like the picture. Also, I like to address the total runoff at the Yichang. It's the gauging station to control the upstream, the Yangtze River has decreased by the 14 billion cubic meters related in 1950s. Another is the very serious for extreme events. Just last year, the major flooding in the Yangtze resulted in the huge sewage and the economic loss. So this is the why we had to think about the climate change. But as the opening ceremony, the Professor Jen Liu is mentioned, because the impact of climate change is a very complex system. It's to cover the natural variation, but also the CO2, the contribution. But in my research team to do our most the 10 years of research, we have the focus on the eastern monsoon area, including the Yangtze River is #1, the largest river in China. But it showed the natural variation role could be reached the major, the 2 to 3rd. But however, the CO2, the contribution also reached the 1 to 3rd. But this means the average, not in the different region have. But I like to address is for water security issue for water resource management before it never think about the impact of climate change. So this is the problem. So we should be think about the risk from the impact of climate change, particularly for the CO2. Another thing I like to address is for remarkable the land use coverage change is also very serious, because these 2 factors impact the coupling that together. These are rising, the very serious the water security issue, because we are thinking about the water security, it's very important. In the Yangtze River, where the industry in history is also led the water environment, the issue, also river development, such as building the dam. But this played key role for flooding control and the power generation. But also, should be would be how to balance for the power, also for ecological the problem. Such as in the Yangtze River, the Chinese the sturgeon has the despair. Also, 4 major domesticated crop has been greatly reduced. Another is lake eutrophication. Just like the picture, the Taihu, the downstream and the Yangtze River. So I like to address this water security issue has become the most important issue for sustainable the Yangtze. These are not only for water shortage, also water disaster, water pollution, the ecosystem degradation, the link with the the region, the socio-economic development. So this rise in the set of the challenge. But I think also the opportunity for future of the Yangtze, because we are living the earth with the future earth, but what is the future Yangtze? So I like to address this, the issue, my presentation, the major one, opportunity and the challenge. Challenge 1, how to coordinate the contradiction between the development and the production. I think this is the big issue for Yangtze River. The Chinese government or Chinese people do the good job for this. But I like to emphasize since 2016, the great production and green development of the Yangtze has been addressed by our President Xi Jinping of the China government. This has become the big issue for China's sustainable development. What does it mean, the green development? The green development is the attempt to describe the effect to go about the process of the developing the model. It's how kind of the socio-economic model. But this is focus on the river system in a manner that take into account the environment and the ecological needs of that community. I think this is the key, the point. Also, if I do the green development, I think the institution innovation is very, very important. So also Yangtze River Protection Law was passed at the 24th Standing Commission section of the 13th National People's Congress last year. So the equal water security is emphasized because we said the water security linked with the water supply, the flooding, the drought, the water pollution, etc. What does it mean, the equal water security? It means it's crucial to extend for ecosystem, such as forest grass, the cover, river, lake, wetland, coast zone, and human settlement, etc. This is serve for human survival and development demand, also linked with the water cycling in the basin, even in the climate change global scale. So this for ecosystem not allowed to be damaged and polluted. That's challenge one. Challenge two, how to manage water, in wisely managed water in Yangtze River. So need developing some innovation with namely the system integration way, apply the multiple dimension for water, biodiversity, ecology service, resiliency to climate change to maintain the ecological human development in sustainable way. So eco-hydrology and other science and technology played a key role for restoring the Yangtze. Also, the Yangtze River Simulator was developed, which can be the effective tool for monitoring, modeling, nexus for artificial intelligence support. This means that we need to integrate the different aspects for water and manage. So this framework for Yangtze River Simulator, there are two pillars. One is observation and monitoring system. Another is a multiple different scale for modeling system for water, soil, atmosphere, social, and economics. So how to integrate together? So this is the basis to support the natural basic solution for green development in the Yangtze River. So this emphasized to integrate the data monitoring system for the whole river basin. It's also a big job. So we need a high technology and from the space, remote sensing, or the network for the river system, surface water, soil water, the groundwater, and the urban area, etc. Second is modeling the change of the hydrological process in the whole river basin from upstream to the downstream. It's also need to modeling the change of the cycling and the climate change, the land use curve change, and it also is interaction with the social economic development, because we have a shoreline, we have the power station, we have the urban area, we have rural area, the link with that together, then support the green development of the Yangtze River. So the integrated system, the solution for integrated river basin management, needed to coordinate in the relationship among the upstream, the midstream, the downstream, human, and the nature. Also should be emphasized how to quantify the carrying capacity, the red line for resource, environment, and the ecology. Also need a support solution by integrated way, because we have a different user sector with how to balance of the different user from the upstream, the lake, reservoirs, shoreline, the urban area, and the delta, the estuary. So the solution, the government, I know the government is changing its role from the economic agent to be in the pioneer for green development and protecting the Yangtze River. For example, in the initial 10 years fishery ban in the whole Yangtze, you will see from the news. Another is for what pollution the issues, we need to do the water quality management through the good water governance. For example, the Chinese, the government is emphasize the river chief system to give the source control for the different basin. For the ecosystem, it's emphasized the nature-based solution. For example, environmental flow, the manager, for we have built the dam, we need the balancing for the fishery requirement. You will see the number of the species, the species is in recent years is significant rising. This includes the the artificial breeding and a different way, should integrate the different way. Also, the nature-based solution for applied to the urbanization, because most people is living in the urbanization. In the China, we have the urbanization is rising. In the Yangtze River, the upstream, midstream, downstream, the upstream, the Chongqing city, and the midstream, the Wuhan, and the downstream, the Nanjing and Shanghai. So sponsor city construction based on the RID, it means lower impact development technology, and also the integration through the city water, methodology. It's linked with the together, the water system, the way to give the solution for the green, development in the city, because the city will face the water logging, the water pollution, the lake, eutrophication, people living in the green. So this need the system in the way. Finally, I think the solution for capacity building. These are still the challenge, but I think there's also opportunity. For example, the upstream, the Yangtze River is there very beautiful, the island of Guangyang Island, the Chongqing city, the Yangtze River. So for this, the Great River Civilization Museum has construction, the quality of the ecological civilization, education for our, the people, for the student. Also historic record of the Yangtze River to understand how to pass the Yangtze and present the Yangtze, what is the future Yangtze. So I like to give my conclusion, the remark. Number one, the Yangtze River faced the big challenge on his water security issue and the climate change, but also land use curve change due to the high intensity human activity, because China will have the high population. Second, the strategy on the green production, great production, the green development, the Yangtze River, this provides a new demand, also the opportunity on how to wisely manage water. The Yangtze River simulator is another integrated way, include the institution innovation. Yangtze River the law was the development and applied to the integrated river basin management to the change the environment. So I say how to take adaptation for impact climate change. This is the way we need to consider the need to practice. So lastly is the Chinese scientists through the ANSO and the Belt and Road Initiative did some of the job, and they expect more international cooperation on river basin practice in the world. Thank you very much. This is my presentation.
Thank you very much, Professor Xia. It's very interesting. And please, I want to remind you all that the questions, if you have questions, people keep them till the end of our session. As I just was informed, there are a few thousand people watching us. So of course, there will be probably a lot of questions, and we have to be ready to answer only the most principal questions. That I don't know how much time we will have in the end. Okay, now I'd like to welcome next talk of Professor Arun Bhakta Shrestha, Regional Program Manager of the International Center on Integrated Mountain Development, to give a presentation on the topic, water resources in Hindu Kush Himalayan and its possible fate under climate change. Please, Professor.
Thank you, Chair, and distinguished participants. It's a really great pleasure to be here and be able to present on this topic, water resources in the Hindu Kush Himalaya and its possible fate under changing climate. And my previous speakers have also touched upon this region, what has been happening. They talked about third pole, and we are talking about the same region. Just to start with, I would like to introduce the International Center for Integrated Mountain Development. This is an intergovernmental regional mountain knowledge, learning and enabling center, which is devoted to sustainable mountain development for mountain and people. Our working area is called Hindu Kush Himalaya, and some people call it also third pole, which is the same. And I will show you that area very, very soon in the next slide. Being an intergovernmental organization, we have member countries, and these are the countries sharing the Hindu Kush Himalaya region. And these are Afghanistan, Bangladesh, Bhutan, China, India, Myanmar, Nepal, and Pakistan. So these are our member countries. So here I'm showing the Hindu Kush Himalaya region. This is India, and this side is actually this side is China. Starting from the far top, this is Afghanistan, Hindu Kush mountain range, then Karakoram in Pakistan, Western Himalaya in India, Nepal, Bhutan. This is part of China, Bangladesh, and Myanmar. So this is the Hindu Kush Himalaya region, and we know it is a monsoon-dominated region. You know, in summer we get southeasterly summer monsoon, and in winter we get westerly disturbances. Uh, and this two circulation system is also source of moisture in this region, which supports huge amount of snowfield, glaciers, and permafrost in the region, and also is the source of water supply of 10 major river basins in the region. Now, as opposed to the two, the poles, the North Pole and South Pole, this third pole is different because there is a lot of people living in this region. So in the Hindu Kush Himalaya region itself, the yellow dotted map area, there are about 260 million people living. The data here is a little bit outdated. But if you count the number of people living in the whole river basin, the 10 river basins, it is 1.9 billion people, which is kind of a quarter of the whole global population. So what is happening in this region in terms of climate change and its impact will actually impact a quarter of the global population, which is a very significant, uh, number of people. So we have to be very careful what happens here, and then we have to see what can be done to actually reduce the impacts, reduce the risk. So to get into the subject matter, I think we are talking about water resources. And in this plot, what I'm showing is flow hydrograph at different locations in the region. You know, no matter where you look at, this is Ganges, this is Irrawaddy, this is Mekong, Yangtze, which was just shown earlier, Brahmaputra, Indus, and Kabul River, right? So these are very different places, east to west. Of course, the magnitude, the amount of flow is different. I mean, small river, big river, but no matter where you go, you can see this clear, seasonal variation, peaking in the summer and then, low flow during other season. That is kind of the general pattern of flow in this region, right? So now, there has been a lot of discussion about climate change and what will happen to the cryosphere and what that means in terms of water availability in this region. And there have been some speculation that there will be a water crisis. So we, together with different international scientists, started looking at it. And the work I'm presenting here was published in 2014 in Nature, and this actually shows in current scenario what consists of the flow in Hindu Kush Himalayan region. These are the upstream part of Hindu Kush Himalayan region, and these are like glacier melt, snow melt, and rainfall runoff. You can see that in the western Karakoram, the glacier melt is the dominant composition of the flow, whereas in the east it is quite low. Green is low. Then in snow melt, Kabul River basin is red and yellow, so dominated by snow. Then if it is about rainfall runoff, then the eastern river, these are the tributaries of Ganges. These are more red, so these are more rainfall dominated river system, right? So it is also presented in the table that upper Indus Basin, 41% is by glacier melt, 22% is by snow melt. Whereas in upper Ganges Basin, it is only 12 percent by glacier melt and 9% by snow melt. And in upper Brahmaputra Basin, it is 16% by glacier melt and 10% by snow melt. So this also tells us that what happens if the glacier melts, where it is going to be more important. Of course, it's going to be more important where the glacier melt is the dominant component of the flow. Now, talking about climate change, this was published in 2019 in what we call the Hindu Kush Himalayan assessment, and this is also based on CMA, Chinese Meteorological uh, Authorities data. What I can say is that in the whole Hindu Kush Himalaya region, also the overall pattern of temperature change is pretty much similar to what is happening globally. Of course, the magnitude might be different. Um, and what we see is that it is around zero point 0.2 degrees Celsius per decade, which is happening in this region, which is comparable to the global average, a little bit high compared to some region, but not the highest one. But what we see is that this is going to intensify in the future. And even if the world manages to stabilize at 1.5 degree, this region will continue to warm at least at 2 degrees. And current scenario will lead to 5.5 degrees in average by the end of the century. So what does it mean in terms of glacier change? This is again from the same report, the Hindu Kush Himalaya report, chapter on cryosphere. Overall, this tells that majority of the regions, the glacier recession has been observed in past decades, and there has been compared to pre 2000 and post 2000, there has been intensification in shrinkage of glacier. Of course, there are some areas in the in Karakoram and Pamir that some of the glaciers are stable, right? But in other areas, majority of them are under receding condition. um, Now, we try to project this under different climate change scenarios, and here what is presented are for 1.5 degree warming for RCP 4.5, 6 and 8.5. These are clustered around here. And for 1.5 degree, it's basically, we see that by the end of the century, uh, around 36% of glacier mass will be lost. So that is 1/3 of glacier in Hindu Kush Himalaya will be lost. But if we go by, current scenario, which is RCP 8.5, we'll lose 2/3 of the glacier ice, which is quite significant number, But then when we look at what happens to the water resources, I think that is the main, topic of this presentation. These are little bit small graphs, but what I saw is, different components of hydrology in different places, and how, with in the middle of the century, the reference period and simulated flow, reference flow and simulated flow compares, right? So what I would like to explain here, of course, you cannot see so well, apologies for that, is that there is not much difference in the flow in reference and simulation in the in middle of the century, which means that even with this kind of climate change scenario, the catastrophic kind of water scarcity probably will not happen, but at larger scale, at large scale, at basin scale. But if we look at small scale, I think the story will be different. I will talk about a little bit later. And we also, this is a very recent publication contributed by our colleagues, published in Nature Reviews, and looked at, what could be the glacier runoff peak period. And this gives you an idea. Of course, the peak period will be delayed quite a lot in the Karakoram upper part of the Indus areas. And this is the Ganges area, where it will be around, 60s, 17, and 70s and 80s. But in the majority of those areas, it will be around 30, 40, that the glacier peak runoff will occur. And after that, probably there will be decline in runoff, right? So then we also have, I would like to present this publication, which came out 2 years ago in Nature, which looked at all the water towers in the world, not only in Hindu Kush Himalaya, and developed water tower index for all of that, which is index which uses water supply and water use as an index, and try to compare. And then we found that three of the river basins in Hindu Kush Himalaya came at top in the water tower index, meaning most vulnerable. And these are Indus, Amudarya, and Tarim River Basin. Indus being the top one, is the most vulnerable according to this study related to climate change. That also shows the importance of climate change here. Now, I said that water is not going to reduce at basin scale, but when we look at small scale, catchment scale, it is quite different. And these are just some pictures from, upper Indus Basin in Pakistan. It's called Pasu Glacier. And these are the pictures from 2009 and 2014. And then what you see in the left are irrigation canal coming from the glacier directly. You can see water actually flowing in 2009, and 2014, there is no water because the glacier has gone down and the canal has been dry. So this is a very kind of local issue, which is quite different from, large basin scale issue. So we also need to look at local issues. So, places like this is now Ladakh in India, which is very arid. Here, the only source of water is from snow melt and glacier melt. Without that, there is no water. But then, there are a lot of area in Hindu Kush Himalaya which are not snow and, glacier supplied. And these are spring fed. Like these are some of the spring fed, and a lot of time women actually go and collect water. There, drying of spring is a very big phenomena. And, a lot of water scarcity is felt in that part of the area where snow and glacier melt is not providing water. Now we have talked about general water availability, right? Long-term changes. But what we also find is that extreme is also changing. And according to this study in PLOS One, what we have found is that by the end of the century, for let's say the current scenario, RCP 8.5, the 50-year return period flow might double in average. that means the extreme flow is likely to increase quite dramatically. Doubling of 50-year return period flow is a quite significant number. So floods is likely to happen more frequently and more, intensively in the future. And this picture basically just showed, that how disasters are increasing in the Hindu Kush Himalaya region. These are mostly the floods. Uh, Now, very much associated with climate change and glacier change is this formation of glacier lakes and outburst of glacial lake. This is one example from Nepal in Everest region called Imja Lake. And here what I saw is a hydropower dam, which was almost completely broken by this flood in 2016. And what is important, the lake was very small, not compared to the one that I saw in the left of this picture, very small. And that lake was, this happened in Nepal, but the lake was located in China, Tibet autonomous region of China. So transboundary risk is also very important. And I think uh, Nepal was not aware of this happening and was taken by surprise. So if we could have some mechanism to share this kind of flood information, it would have been very beneficial. And this is just an example. It could be, valid for many other, countries. So I think we should have some mechanism for, sharing of information, and probably ANSO could be a platform which can actually support that kind of sharing of information. Now moving on, also taking this a little bit to a broader scale, again from the same Nature review, this shows the blue dot shows the location of glacial lakes, red dot shows past GLOF events, and then the circle shows different hydropowers. Actually hydropower stations are increasing in this region, and they are moving further upstream to the mountains. So the risks are getting also very high. We knew about this case in India, where this flood happened in Uttarakhand, and hydropower were damaged quite, significantly. So hydropower is becoming at very high risk. Although energy is very important, we should also be, very careful about, the safety of infrastructure. So this is what I would like to, present to you in terms of what we know about climate change, cryosphere change, and what is happening to the water. Not only the gradual trend, but also the extremes and what are the risks. Now coming to my concluding slides, couple of slides. I would like to say that with that, I think what do we do? I mean, understanding the problem is one, but I think we need to take action, right? So we need to actually adapt to the changes. Changes will happen. We can reduce the rate of the change, but I think adaptation is very important. So there are risks in those river basins. So we need to minimize the risks, and these risks are related to glacial lake outburst flood, rainfall flood, drought, erosion, sedimentation, landslide. There are many different risks. So we need to identify what are the risks in those river basins, and also know how the small scale risk hazard in small scale actually links to a larger scale, how the risks are connected across the scale. And very importantly, we should not only look at the biophysical part, we also look at the social part. So understand who are the vulnerable groups, because the hazard, impacts different groups of people differently. So I think we also need to understand who are the vulnerable groups, what are their vulnerabilities, and then with that, I think we need to change it into positive aspect. That means maximizing benefits. Of course, the river basins provide drinking water, irrigation, biodiversity support, hydropower support, and industry. So we need to identify, while reducing the risk, what are the opportunities related to water resources, how to balance the water uses across the sectors. There are different sectors, sometimes conflicting. So how to balance and create synergy between different sectors, and also understand who are the beneficial groups, right? And how the benefits can be shared with other groups. who are custodians of the resources. Sometimes there are also conflict because benefit is taken by a completely different group of people, and the people in that area are deprived of the benefit. So I think we need to also think about how to, share the benefit. So this is what I would like to present here. Thank you once again for the opportunities, and if there are questions later on, I'll be happy to answer to them. Thank you so much.
Thank you, Professor Shrestha, for very interesting talk. Next presentation is from Professor Tianchun Zhou from the State Key Laboratory of Numerical Modeling for Atmospheric Sciences and Geophysical Fluid Dynamics of the Institute of Atmospheric Physics of the Chinese Academy of Sciences on natural and anthropogenic climate change in Central Asia. Please, Professor Zhou.
Thank you, Chair. Dear friends, this is Chu Tianjun from Chinese Academy of Sciences. Today, I will talk about the changes of precipitation in Central Asia. For the background of this work, one question you might ask is, why do we care about Central Asia? The answer is, this area is quite sensitive to climate change. And here is the area of Aral Sea. You can find we have a 90% reduction in the past decades. Another case is the glacier mass changes in the Tian Shan Mountain of China. You can find decreasing trend in the past decades. This kind of change is partly related to global warming. And here is the observed and simulated surface air temperature averaged over Central Asia. You can find a significant warming trend. And more important, based on the projection, you can find in the coming decades and the century, this kind of warming trend will continue. So one question many people may ask is, how about the precipitation changes in the near future? And here is the climate mean precipitation in the observation. You can find Central Asia belongs to arid or semi-arid area. For the annual cycle of precipitation observed here, you can find we have a difference in the south and the north. In the North Central Asia, the annual cycle peaks in summer, while in the southern part, it peaks in winter and the spring. So in the following minutes, I hope to answer two questions. First, how about the changes of precipitation in the past decades? We will try to do attribution studies. The second, we will answer how about the future changes of precipitation over this critical area. In the first part, we try to identify the water source of the historical changes of precipitation. In this part, we have used a Eulerian water source tagging method. This kind of method is used along with a numerical model of CAM5. We have run more than 50 years simulation with specified historical sea surface temperature and sea ice. And then we will check whether the observed trend of precipitation can be reproduced in the model world. To identify the moisture source, we need to define the moisture sources. And here, we have defined 25 moisture sources around the world. And we'll try to trace the origins for the precipitation in North Central Asia and South Central Asia. And here is the result for the climate mean state. This one is for North Central Asia, and this one is for the South Central Asia. Different colors indicates the contribution from different parts of the origins. For the North Central Asia, to make a summary of this complicated figure, we found Europe, North Atlantic, and local evaporation can explain 33, 23, and 19% of the precipitation. For the South Central Asia, we can find Europe, North Atlantic, and the local evaporation can explain 26%, 18%, and 15% of the total rainfall. In the meantime, the contribution of South Asia and the Indian Ocean are more than 18%. So they are also very important moisture sources for Central Asia. Our interest here is the long-term trend. How about the observed changes of precipitation in the past decades? What I shown here is the precipitation in the spring and the summer. We found in the observation in the springtime, the southern part of Central Asia has witnessed a drying trend, while in summer, a drying trend is evident only in the northern part of Central Asia. And here are the results of the simulation. Generally speaking, you can find the observed drying trend in spring or southern part and the summertime in the northern part can be well reproduced in the model world. So we can use models to trace the origins of the water sources. And here is the result for the South Central Asia. Here are the linear trends in spring precipitation over South Central Asia contributed by different source regions. To make a summary, you can find the contributions from the Arabian Sea, local evaporation, and the Arabian Peninsula are significant. So the decrease trend of the South Central Asia in springtime is mainly due to the decrease in the local evaporation and the weakened moisture fluxes from the Arabian Sea and the Arabian Peninsula. If we add the sum of these three terms, you can find the drying trend is nearly identical to the precipitation. We have also analyzed the physical mechanism behind this, and we found the reduction of the local evaporation is associated with the weakened near surface wind, as shown here, and also a cooling trend over Central Asia. How about the moisture source contribution to the drying trend in the North Central Asia? Again, here are the linear trends for different sources. You can find the contribution from local evaporation and also the Northern Europe are significant. The sum of them can explain about 2/3 of the total precipitation changes. Again, if we add the local evaporation and the moisture source from the Northern Europe together, you can find the pattern is nearly identical to the total precipitation changes. Behind this count of change, we highlight the local reduction of the evaporation actually is contributed by the drying trend in soil moisture and also the decline in the lake area. This suggests a feedback of the soil to the atmosphere. To make a summary of this part, we highlight for the moisture source attribution of the observed precipitation changes. For the drying trend of South Central Asian spring is due to the decrease in local evaporation and also the weakened moisture flux from Arabian Sea and Arabian Peninsula. For the drying trend of North Central Asia in summer, is resulted from the decrease in local evaporation and also the reduced moisture from the Northern Europe. Up to now, however, we did not answer the question whether the observed changes are natural or anthropogenic. We'll try to answer this question by the second part. For the detection and attribution studies, we also rely on numerical models. And here is the list of CMAP6 models we used. And here are the list of the experiments we used. Please note the historical simulation means we use both natural and anthropogenic forcings to drive the climate model. For the NAT forcing, that means only natural forcing are specified. For the GHG experiments, that means only greenhouse gases forcing was specified. For the AER, that means only anthropogenic aerosol forcing was specified. How about the observation? Here again, it's the linear trend of summer precipitation derived from the observation. You can find a drying trend in the northern part of Central Asia. And here is the time series for the average of different observations. You can find the decreasing trend. And the superimposed on this kind of a linear trend, there are interannual variability. What kind of atmospheric circulation have dominated the precipitation changes? Here, we highlight the subtropical westerly jet at 200 millibar. What I show here is the first two leading UF mode of zonal wind at 200 millibar. For the first mode here, you can find it indicates actually a southward shift of the westerly jet. For the second mode shown here, it indicates a weakening of the westerly jet. Associated with the westerly jet change, here is the surface circulation changes over the Central Asia. You can find both of them are not favorable for the precipitation in the North Central Asia. So based on this analysis, we highlight the drying trend is dominated by the southward shift and the weakening of the upper level subtropical westerly jet. Then next question you might ask is, what kind of forcing are responsible for the westerly jet changes? Here, we compare the changes of the westerly jet in observation and the model simulations driven by different agents. Here is the result of the observation, and here is the result of the historical simulation. You can find both the southward shift and the weakening can be reproduced. If we only specify the greenhouse gases, however, we can only find a southward shift of the jet. If we only specify the aerosol forcing, we can only get a weakening of the westerly jet. If we only specify the natural forcing to the model world, there will be no signal. So based on this, you can find both the greenhouse gases and aerosols have contributions to the observed changes of the westerly jet. To make a summary for this point, first, North Central Asia is facing a reduction of the summer rainfall since the 1950s. The drying trend is dominated by the southward shift and the weakening of the subtropical westerly jet. And the third, the observed changes in the westerly jet are actually dominated by the forcings from greenhouse gases and anthropogenic aerosols. All these are evidence for the past observed changes. The last question I hope to answer is, how about the future? To answer this question, I will show the result of projection, a scenario-based projection. Here is the list of 15 models we used from coupled model expand CMAP 6. And here is the projected changes of annual mean precipitation averaged over Central Asia. Different colors correspond to different scenarios. You can find for the average over Central Asia in the coming century. In the near future, as shown here, actually the response of Central Asia precipitation to external forcings such as greenhouse gases are not so significant. However, if we focus on the long term and the midterm as shown here, the response are robust. And here are the list for the estimate of long future projection. You can find under all four scenarios, there would be an increase of annual precipitation over Central Asia. And here is the response of precipitation to per degree of global warming for 4 scenarios. You can find positive response under all 4 scenarios of Central Asia. So this kind of response is robust. Another point for the precipitation changes of the Central Asia is the annual cycle. The left is for northern part of Central Asia. The right is for the southern part of Central Asia. Please focus on this. If we focus on the North Central Asia, you can find the black line is the seasonal cycle for the present day. Different colors correspond to the near-term, mid-term, and the long-term projection. You can find under all scenarios, we have 2 features. The first is the wetting trend in spring and the drying trend in summer. This suggests an enhanced seasonality in the future. We also try to provide a physical understanding of this kind of changes in the seasonal cycle. We have used the moisture budget. I will skip the details. The answer to the physical understanding is that the wetting trend in the spring actually is balanced by the increase of the evaporation. For the drying trend in summer, is dominated by the decrease of vertical moisture advection. Both the so-called thermodynamic term due to the changes of humanity and the so-called dynamic term, which is related to the atmospheric circulation, both of them have contributions. The last question you might ask is, how about the extreme precipitation? We know the impact of extreme precipitation on the society is larger than the mean state. So we analyze the extreme precipitation by using the models listed here. We also try to answer the question, how about the extreme precipitation changes under the global warming targets posed by Paris Agreement? So we have calculated the time for 1.5 and 2 degree warming for different models as listed here. And here is the definition of extreme precipitation index. First, we have dry days index, and then we have 3 extreme precipitation index, such as RX 1 day, 5 day, or SDII. And here are the changes of the projection in the extreme precipitation. First, if we focus on the dry days, you can find there are large spread among the models. We have this kind of projection is highly uncertain. However, if we focus on the extreme precipitation, you can find all 3 index exhibited an increased trend in the near future. So, and here is the statistics, we can find significant increase. And here is the changes in extreme precipitation under Paris Agreement global warming targets for 1.5 degree, 2 degree, and please focus on these 2 targets. You can then find first, the response of the dry days are not uniform. Second, we can find nearly uniform increase of extreme precipitation across the whole Central Asia. Third, if we focus on the difference between 2 degree and 1.5 degree warming worlds, you can find increase across the whole Central Asia. So a ½ degree more warming actually would lead to a significant increase of extreme precipitation across the whole Central Asia. We can also provide a quantitative estimate. We measure this here by using the so-called avoided impact or avoided intensification. And here is the result for RX 1 day, 5 day as DDI average over Central Asia. You can find we will have a reduced risk under ½ degree less warming. The estimated avoided impact are larger than 90%, 39%, totally more than 40%. To make a summary for this point, first, for the changes of annual mean precipitation in Central Asia, in the end of this century, there will be a robust increase of annual mean precipitation. In the meantime, we will have enhanced seasonal cycle. We will have a wetting trend in spring, but a drying trend in summer. For the changes in extreme precipitation, during the end of the century, all the extreme index would increase. More important, compared with the 2-degree warming scenario, limiting global warming to 1.5 degree could reduce the intensification of extreme precipitation indices with avoided impacts more than 39%. That's all for my talk. Thank you.
Thank you very much, Professor Joel. Extremely interesting talks. Thank you. Next, please welcome Professor Igor Mokhov from Russian Academy of Sciences, academician. He's a scientific leader of the Obukhov Institute of Atmospheric Physics of the Russian Academy. He will present the talk about the climate anomalies, trends and impacts in the North Eurasian and Arctic regions. Please, Igor Ivanovich, please, your time is now.
I show you some results of analysis of climate anomalies and trends in North Eurasian and Arctic regions, in particular in Russian regions. I'm glad to see at this conference Professor Zhou. We have a long-term collaboration between our two Institute of Atmospheric Physics of the Russian Academy of Science and Chinese Academy of Science. Here you can see the opening ceremony with introduction of the president of Chinese Academy of Science in Moscow, and also by atmospheric physics guru, Chinese guru Yedu Zhen at the opening ceremony in Beijing. So every year we organize the joint meeting in different cities of China and Russia, except the last year. So on the topic of atmospheric physics, climate and environment. Current climate changes are accompanied by the very rapid changes in the extreme disasters and extreme, especially in extreme hydrological and meteorological events. In particular, in Russia, with very fast warming, about half a degree Celsius per decade, it accompanied by very fast increase in the number of dangerous meteorological phenomena, especially in warm time seasons and especially in summer. Up to 40% of these phenomena are in summer. What is the contribution of these changes? What is the relative contribution of natural and anthropogenic changes? With the use of Wiener-Granger causality, we analyze this contribution and found using different observational data and try to estimate contribution to the temperature trends in different latitudinal zones and for the globe on the whole. We use also analyze contribution of key climatic modes like Atlantic multidecadal oscillation or El Nino southern oscillation. According to
Namaskar, Dviji.
Проблема?
No problems, no problems. There's somebody switched his microphone. Sorry.
Okay.
राखेर त छैन, एक दुईजना आइरहेको चाहिँ छ होइन, अघि पनि एकजना आयो।
According to our results, this contribution is different for different time horizons. In particular, for middle and high latitudes, the contribution of natural variability is the highest one. And it is important and comparable to the anthropogenic forcing effects for the time periods about 2-3 decades. But for longer periods, the anthropogenic contribution is dominating. The most bright and most clear climate changes are found in the Arctic, especially in the degradation of sea ice extent. Here I show you some results on the change of navigation period during last decades from satellite data. And you see that a period with open water on the northern sea route is increasing very fast. Over land, we have the largest temperature trends in the high latitudes, in particular in the area of Taimyr, Yamal peninsulas, up to 1 degree Celsius per decade. It's very high, or even more, even higher. And for all seasons, except for some anomalies for winter during last decades. And what is important, this surface warming is accompanied by very significant changes in the vertical stratification, temperature stratification, so-called lapse rate. Increase in the lapse rate lead to the decrease in static stability of atmosphere and increase of frequency, increase and the intensification of convective processes in the atmosphere, and so lead to the increase of probability of extremes, weather and climate extremes. As an example, you can see here trends of the annual total precipitation, also convective precipitation and stratiform precipitation over different North Eurasian regions. And the most significant changes are for convective precipitation with the increased tendency of increase, but for stratiform convection or precipitation, we have opposite tendency with decrease. So the structure of hydrological, so we see a change in the structure of hydrological cycle. It is important. So the convective processes are intensifying during the last decades, in particular during last 6 decades. Here you see more detailed figures for different seasons, or for convective precipitation and for stratiform precipitation. And for all seasons, you see the intensification of convective processes. The same for the intensity on convective precipitation. Last winter is a good illustration of a very intense snowfall. As a very good example, illustration of current climate changes. Model simulations show the reproduce such changes and with differences in different seasons. For instance, at the bottom, you see model simulation for the trend of summer precipitation for the 21st century at an RCP 4.5 scenario. And you see that in middle latitudes in summer, we have drying tendency, except Far East. On the Far East, we have a monsoonal effect. So, but in general, in summer, we have increase of dryness in middle latitudinal regions, in particular over Russia, as well as middle Central Asia, as you saw from the previous talk. But if you look more in details for Moscow region in particular, you see that in general, in summer, we have general decrease of precipitation in the 21st century, but increase in the total precipitation in winter. Intensification of intensity of summer and winter precipitation, but opposite changes for probability of precipitation in summer and winter. Decrease of probability in summer and processes for increase of dryness in these latitudes, and more in the increase in the precipitation probability for winter season. These changes in temperature regime, hydrological cycle, and also circulation, atmospheric circulation, lead to the important impacts, consequences, like wild forest fires, in particular in Siberia. During the last years, we had strong forest fires in Siberia. And at the bottom, you see the illustration for trends in mean fire intensity from satellite data for the last 2 decades. These tendencies are associated both with centennial tendency of climate changes and also with the influence of key climatic modes such El Nino. So the extreme regime like Russian heat wave in summer 2010 was associated with stabilization, with what happened in special phase transition for El Nino. This year, such years are started in the El Nino phase, and at the end of this year was La Nina phase. For such transitions, you can see the structure like Rossby wave stationary regime. The very important contribution to such regional anomalies are related with the blockings, blocking of zonal transfer in mid-latitudes. So in 2010, the maximum of blocking probability in summer was over the Eastern Europe, over Russia, but during the Amur River record flood, it was over Pacific Ocean. In this stationary construction situation led to the extreme Amur River flood. These illustrations for the relationship between fire areas in Russia in warm seasons with the blocking activity, in particular with blocking duration. So there is a significant correlation between areas of fire regimes in Russia with duration of blockings, and also the same for associated annual emissions for CO2, CO, aerosol. It is important to mention here that according to multimodal simulation, ensemble simulations, we have to expect in the 21st century the increase of probability of the most long-lived blockings both in winter and in summer for the northern hemisphere. It means that we have to expect cold winters associated with anticyclonic blocking regimes, and very warm, hot summers for some regions. Another illustration of a rule of blocking situation. This is these figures shows trajectories in the atmosphere of North Eurasia in summer 2016, especially in July. First two plots illustrate the situation during blocking situation with the transportation, with transfer of gaseous and aerosol components from Siberian wildfires to the west. This is very unusual regime, anomalous regime, and this transcontinental transfer is associated with blocking situation. After this blocking situation, see the figure at the bottom, the transportation of black carbon particles from west to east and in the Arctic. It is very important that because black carbon is very important for influences on the albedo of sea ice and snow and change it abruptly. Another effect of blocking also in this year was associated with the extreme temperature over Yamal Peninsula and Taimyr Peninsula. These regions are in the cryolith zone with permafrost, and they are very sensitive to the degradation of permafrost and the example for this example shows that during the blocking situation in July 2016, we found the positive anomalies of methane content over Yamal Peninsula and Taimyr Peninsula, associated with degradation of permafrost. It's also should be mentioned here that during the last years, new climatic effects and new climatic structures was obtained on the Yamal Peninsula. These craters are associated with the degradation of permafrost in the cryolith zone. Finally, I would like to show you some results which, for tornado activity in the North Eurasian regions. This is quite unusual, relatively unusual for the North Eurasian regions. But according to new data, according to new results, we have registered much more tornadoes in Russian regions than registered or mentioned before. It's the formation of such tornado genesis is related with the instability of atmosphere. So the increase in the lapse rate under the warming helps, contributes to the increase of frequency for the tornado genesis. My final figure illustrates our estimates of changes of tornado activity over North Eurasian regions with three climate model of general circulations for to the middle of for the next decades, and to the end of 21st century. These results show that we have to expect the intensification of tornado genesis in not just over Black Sea and in the region of Black Sea, for instance, near Sochi, quite frequent tornadoes, not just on Far East, but also in mid-latitudinal zones inside the continent. This illustration of different sensitivity of different models. This lowest sensitivity for the Russian model in MCM4 and with largest sensitivity for American GFDL CM3 model. But this is so we have to expect under the continuation of global warming and warming over North Eurasia, we have to expect increase in the frequency of these local anomalies, weather anomalies. Thank you.
Thank you very much, Professor Mohov. We have 2 talks more. Now I'd like to invite Professor Philippe Demeyer, Senior Field Professor in the Cartography and Geographic Information Systems of Ghent University, to present on the Sino-Belgian Joint Laboratory for Geoinformation. S'il vous plaît, Monsieur Demeyer.
Okay, I am unmuted. I think I would like to share my screen now. I'm happy to see you all. Okay, normally you must see my screen now. I hope we will not have too noisy background. We are still in Belgium obliged to work at home, and they started yesterday some street works in before my house. So I hope that we can work not too noisy background. So I will speak to you about the Sino-Belgian Joint Laboratory for Geoinformation. So why I will speak about it, because it's not directly the subject of this day, but it's in fact demonstrating how an international collaboration can make research stronger and can, let us say, develop the outcome of different separated laboratories. In fact, we are speaking about 2 institutions. On one hand, Ghent University and the Department of Geography, where I'm working in Belgium. And on the other hand, the Xinjiang Institute of Ecology and Geography, depending on the Chinese Academy of Science, where is working my principal, let us say, colleague, Alishir Kurban, who is also, I saw on the site today. So everything started, and it's a good idea that, in fact, we are today, let us say, coordinated by Moscow. Everything started with a collaboration I had with colleagues from Lomonosov Moscow State University, in fact, Professor Vladimir Tikhonov in 2005, and in the framework of the International Cartographic Association, where he asked me to join him to go together to the Xinjiang Institute of Ecology and Geography. So what I'm telling you is a history of 15 years. It takes a lot of time to develop a strong collaboration, but as you can see in the beginning, we had only teaching activities together. So that was the starting point. And so during, let us say, 7-8 years till the beginning of the year 2012, it was the main collaboration. We were exchanging students, we are exchanging professors, and the first official collaboration started in 2007, and now we are in the third 5th-year term cooperation agreement. That was really the starting point of everything. So afterwards, our colleagues from Xinjiang Institute of Ecology and Geography could have some strong collaboration with CSC for finding funding for to send students to Belgium on one hand, and on the other hand, we had also a collaboration with the Turpan Heritage, the Office of Heritage Studies in the Turpan region. So this brought us in 2016, working already on different subjects of research to start up a Sino-Belgian joint laboratory for geoinformation. Was set up by the Belgian ambassador in China, who went to Urumqi to co-sign this agreement, and afterwards Professor Chun-Li Bei came also to Belgium to open also officially this joint laboratory. What's the purpose of this joint laboratory? Is to conduct academic exchanges and research in different domains, especially in climate change, sustainable development, geoarchaeology, environment, ecology, geography, and geology. So you will see it's wide open, but at the end of the speech, I will show you some typical, let us say, common elements in all of this. And that's how it works today. It's very complicated today. We have the Sino-Belgian Joint Laboratory. Most important things, I put it in these huge letters. We had since 2017 and till now an agreement on double PhDs. I will come back to this. So the students have a double degree, not a joint degree. They have a double degree. They will receive the 2 diplomas, one of Ghent University and one of the University of the Chinese Academy, but this is operated by XIEG. We have also a memory of understanding of working together with the University of the Chinese Academy. And then there are some other, let us say, in this context, other agreements. First of all, there is an agreement between the Royal Meteorological Institute of Belgium, and that's important. I will come back on that also. And the XIEG, and on the other hand, the professors of the RME are also working in the Department of Physics and Geography at Ghent University. So indirectly, there is a second, let us say, connection between both. And then in green upstairs, up on the slides, you have also some other agreements that, let us say, were outcomes of these main agreements that you have in the center of the slide. So in fact, the collaboration is based on 3 pillars. We have common research topics, environment, climate change, geography, geographical information systems. We have a strong exchange of staff and students, including teaching, and the label of all that is joint lab, and you see even the Chinese television in Belgium in our premises, I think 3 years or 4 years ago. So we participated in a lot of conferences together, some pictures here. So we have, in fact, complementary competences. We have, let us say, also very important a personal understanding between the different researchers and professors of the 2 institutes. We have all our own networks. I think that the One Belt, One Road is also an important factor in the collaboration we have with some other institutes in Central Asia. And it's a long term, it goes back to 2005. What are the 2 main subjects? Well, the 2 main subjects is modeling and understanding the heritage issues along the Silk Road. There, my colleagues of the Department of Archaeology are also involved on Belgian side, but the most important aspect of our research is climate change and impact on land use, land cover, hydrology, and soils in Central Asia. with then from Ghent side, the Department of Geography, Department of Physics, the Royal Meteorological Institute, and then again from Chinese side, the Xinjiang Institute of Ecology and Geography. You see the topics: climate change, hydrology, soil moisture. That is what we are looking to together with our colleagues. Let me shortly explain the first subject. It's nothing to do with the main topic of today's lectures. It's modeling and understanding the heritage issue along the Silk Roads. We do it mainly by 3D and 4D GIS modeling of World Heritage sites along the Silk Road. We have a Belgian student, PhD student, working on this changing water landscape. I will come back soon back on that. And we are, let us say, some punctual studies also doing. Is, for example, the petroglyph map study. That's the type of modeling studies we are doing. So we make pictures and we are modeling heritage sites along the Silk Road that is nearby Turpen. We are acquiring data, we process the data, and this brings us to publications. That is mainly done by master students of both sides, and including also staff members. That is mostly master students' research work. The professors are working together on the interpretation of this petroglyph in Korzai Valley, Tucson County, nearby Turpan. It's a petroglyph map that we presume is from the first millennium before the current era. We are interpreting it, and we see it as a, let us say, representation of the large surrounding environment, and there the publication is in a finishing state. I already mentioned one Belgian PhD student that is also working in this collaboration. She is working on the changing, what we call the changing water landscapes in the region of the Flaming Mountains in China on the east of Turpen. She is working with archives. The figure in the left corner below is a picture that was taken in 1904 by a German expedition. She was looking at a lot of archives. She was, let us say, bringing together a lot of historical pictures from more than 100 years ago. She is working with satellite imagery, and then she is, by walking on the field, she is observing how this landscape changed and how the, let us say, the use of the water in the last century changed. So I'm coming back to the main topic. Already I see that in the last years we are moving somewhat from research work from Western China also to Central Asia up to the Aral Sea. What is the output? What is the, let us say, the subjects we were studying together? So you see here a list of defended PhDs. Two of them were before the cooperation agreement for joint supervision, but the two first ones were also a joint supervision. But now we have, let us say, a frame agreement for supervision of the two universities together. And we have, let us say, an increasing number of students that defended their PhD, that is in the 2016 to 2019. We had past year 6 Chinese students finishing their PhD. So in total, we had already 13 students working on different subjects that finished their PhD, except, let us say, some cases of one working on transport network, one working on hydro issues in the Sanyang Plain, and one working on the atmospheric CO2 concentration, and the one that I already mentioned on water landscape. All the other ones were or are working on hydrological processes and impact of climate change. And the common thing is that, in fact, they are all working on mapping and modeling using field observation imagery and GIS techniques. And as already mentioned, Western China and now more and more Central Asia are the regions we are working on. Already 13 defendants and 13 other ones that are in the pipeline. Joint publications, the number of publications on the Web of Science is in total since 2015, 60. So that seems for me an important number that was only possible by integrating the know-how of the two institutes, or Ghent and CIEG. We can see it also in a larger context. CIEG is for Ghent also opening the door to other institutions, the UCAS. It's by CIEG that we came also in contact with UCAS. The other CAS institutes, we had the opportunity to visit and perhaps to develop some further collaboration later on. I mentioned them there, but also with other institutions. I had the opportunity in December 2019 to visit Wuhan University, but also a lot of other universities in China. I was in touch with, and I visited the Academy of Surveying and Mapping and different, but it also brought us in contact with different academies in Mongolia, Kazakhstan, Kyrgyzstan, and further on. During the different congresses, we participated in a Sino-Belgian joint lab. And in fact, also the ANSO is one of the contact points that we were integrated by this way in. But our lab in Ghent has also other, let us say, other collaborations. And first of all, the Royal Meteorological Institute in Brussels. We are involved, and I think it's also important because it's on the impact of climate change and changes in climate extremes. It's a project funded by the Flanders Research Foundation, but also by Russian, by European money. Sorry for Russian. It's an ERANET Rus Plus. It's a project where Russia colleagues are involved, but also colleagues from Germany and Turkey and other countries. And tomorrow in the afternoon, one of the colleagues, Sarah Top, will explain and discuss about that, what she is doing in the framework of this project. So we have also Mongolian students in our lab. And coming back to the past, to my first slide, we have now also a project, I especially put it because there are some Russian colleagues with the Russian Science Foundation about the development of the concept, technologies and services of an Atlas information system next generation for monitoring the parameters of the environmental situation in the regions and city of Europe and Russia. We are collecting data on websites, and we are looking how, let us say, the environmental situation is appreciated in different countries. What's now the social benefits? In fact, it's exchange of students, exchange of staff members, discovery of different cultures, networks with our old students. Most of the Chinese students are now young professors in different Chinese university. Dus we also not only supervise the PhD students, but we intervene in courses on both sides. So the disadvantages are manifold. We learn to work together, but I see that it's impossible to have the important output as we have now today. It's impossible if the both parties would not work together in a structure, this Sino-Belgian joint lab for geoinformation. Okay, I thank you.
Thank you very much, Professor De Baer. And we have the last talk will be given by two speakers from Mongolia, Professor Avirmet Dasteren and Professor Balt Suvdantsek, sorry. They are from Mongolian Academy of Sciences. And the topic of their presentation will be climate and environmental changes affecting pastoral systems in Mongolia. Please, professors, you have the floor after a short video.
First of all, thank you very much for giving us opportunity to attend this conference. As you mentioned, that we will talk about the climate and environmental changes affecting pastoral systems in Mongolia. So our presentation is divided to two sessions. First, I will talk about the climate and environmental changes in Mongolia. After me, the Professor Sobunjitsi will talk about the pastoral systems in Mongolia. So where is Mongolia located? I think all of you know the location of Mongolia, but I would like to highlight some special issues in Mongolia. So as shown on this map, Mongolia is located one of most warming region in the world. Also, as shown on this map, Mongolia is located the southern boundary of Siberian continuous permafrost zone, and this map shows the biomass in the northern hemisphere. According to this map, we can see that Mongolia has several biomass and natural zones. So all of these conditions make the Mongolia sensitive to climate change. So how is climate changing in Mongolia? The previous researcher has shown that the Mongolian air temperature has increased by 2.4 degrees Celsius. This is almost 3 times higher than global mean. Of course, this climate change is making some problems in relation to environmental. And we can see, for example, we can see this climate changes is driving the land cover change, permafrost degradation, glacier loss, desertification, ecosystem degradation, drought, heat wave occurrence, drought, and surface water storage. You can see 2 examples as shown these photos. This is a desertification in central Mongolia, which is very popular phenomenon in Mongolia now. Also, this is river, dry river, but not full year, which is Tol River, located in central Mongolia. Sometimes there is water storage in Tol River, especially in springtime. Of course, this environmental changes issue is very big topic, but today I will talk only about the permafrost degradation and glacial loss in Mongolia because of the time. So this map shows the permafrost distribution in Mongolia. As shown this map, that the permafrost occurs in north part of Mongolia in high mountain areas usually. So the distribution of permafrost roughly overlay with mountain areas, also forest and high mountain natural zones. Of course, the permafrost occurs in the cold area of Mongolia, but there is huge seasonally frozen ground in the south part of Mongolia. The permafrost occupies about 28% of total land area of Mongolia. So we have very good permafrost monitoring sites in Mongolia, and you can see you can see the monitoring sites. This red color shows permanent measuring the permafrost temperature, which is about 90 Warhols we have. In order to monitor permafrost, we are using now some hubble logger, which measures the permafrost temperature every 4 hours. So of course, the monitoring sites are located in different landscapes. For example, this site is located in Alpine and with continuous permafrost area, while this site is located in steppe area with a sporadic permafrost zone. Therefore, the monitoring system is covering almost all landscape types in Mongolia. So now I would like to briefly introduce about the permafrost situation in Mongolia. This plot shows the permafrost temperature, and the temperature of permafrost ranges from almost 0 to minus 3.5. And also, as shown this plot, we can divide two permafrost. One is warm, which is below minus 1.5. Another is cold permafrost, which usually occurs in continuous and discontinuous permafrost region. And Mongolian permafrost is degrading. For example, this graphic is showing some temperature, the long-term temperature series from the monitoring sites. And this result shows that temperature is increasing with different ratios. For example, these sites are located in the north part of Mongolia. There is increasing trend is larger than the south boundary of permafrost, as shown around these lines. Excuse me. In Mongolia, permafrost is not only warming, but also it is thawing. For example, this Irtnis site, it is located near of the south edge of permafrost in Mongolia. In 1984, there was permafrost, as shown this blue line, but 2016, this permafrost has disappeared. Also, same pattern also observed in KH 36 per hole in Khinty Mountain. Also, we can see that after disappearance of permafrost, the ground temperature is rapidly increased, as shown this plot. So now I would like to talk about the glacier situation in Mongolia. Now in Mongolia, we have about 370 kilometers square glaciers in Mongolia, which belongs to 47 mountains in Mongolia. Also, we are monitoring the glacier environmental condition at several glacier mountain area, as shown this photo. Of course, the glacier are main source of water, especially in Mongolian Altai mountain. The speakers already mentioned about it. It is also same in Mongolia. And Mongolian glacier stores about 10% of water resource in Mongolia. So how is changing in glacier in Mongolia? And both satellite image and observation data shows that Mongolian glacier is shrinking. For example, this we this site is located in Tappenberg Mountain, which is largest glaciated mountain in Mongolia. And from 2016, the lower boundary of glacier is going up. Also, this pattern also observed several glaciated mountain is shown A, C. And this glacier degradation also confirmed why some field photo. This photo was taken in 1910 by Dr. Cartors and in Turgun Mountain, and we took photo in 2010 after 100 years. And now you can see the real changes of glacier. And the lower boundary of glacier moved up to more than 300 meters, and it is lifted by 50 meters almost. The glacier is not only changing in the lower part of lower part. Also, it is changing the top of glacier. For example, you can see in 1910 there was glacier around here, but now it is disappearing 2010. And same example we can see Mukherjee Mountain, which is located in Alta Mountain. It was took 1998 and 2010. For last year we took it, and the compression these photos also show that glacier is decreasing in Mongolia from year to year. So conclusion is that we have very, very good monitoring system for permafrost and glacier in Mongolia. And generally, it is well known that permafrost and glacier are decreasing. But there is study gap, the interaction between permafrost, glacier, and social economic issues, including pastoral system condition in Mongolia. Therefore, we have to consider the permafrost glacier issues into the special development plans and pastoral systems, as well as human settlement, urban planning, and regional planning in order to reduce the negative permafrost and glacier risks. Thank you very much. It was my presentation. Now I would like to invite Dr. Sopnjitsek.
Hello, good afternoon, everyone. My name is Bat Sopnjitsek. I'm working in the Mongolian Academy of Sciences, the head office. Yeah, thank you to all the presenters and the organizing committee to giving the opportunity to talking in this workshop. Yes, I following the Dr. Dashtirens. We are collaborating, and I just talking about the climate change and its impacts on the pastoral systems in Mongolia. But we will be talking. I will be talking this some of the results very briefly. Sorry, this one is. Why it is not okay? Yes, before my talking, I would like to explain about background of my study. This graph shows about the working forces and the land use of the country. For example, it's seen from this map, the animal husbandry is the working force of the country. Almost 22% of the people are working in the animal husbandry, and it is using the almost 80% of the land. And also it is contributing about the 11% of the GDP of the country, which means it's like a very important part in the countries. social and economy system. That's why our research is more focusing on the pastoral systems. Yeah, why, how the climate change and climate extremes are affecting the socio-economic of the country and also the pastoral systems is seen from this slide. Most of the climate extremes are happening during the summer and also following the winters. For example, it's seen from this map. This graph, you can see that the sharpest of the changes on livestock numbers from 1970 to 2014. It's seen from here that most they're happening the two term of the sharp downs on livestock number, which means showing the big impacts from the climate related extremes. Tied to this climate extremes, we are losing a lot of the number of livestock, which is impacting the economy of the country. That's why we are considering to adapting in this kind of the climate change issue. Yes, now we are working on the several projects, but the most related one is the last one, which I talk today. This is more relative project about how climate change is affecting the pastoral systems in Mongolia. Yeah, actually this project is including the two countries and the three provinces and sub-provinces from Mongolia and China. But today I will be talking about only Mongolian case because I didn't considering more about the China case. But in this project, we are working with the very good project group teams from China, Japan, Australia, and Mongolia. And we also learned many things from the China side and exchanged the good experiences. Why we choosing these two provinces from Mongolia is these two provinces are most vulnerable areas affected by climate change and climate change related extreme disasters such as like drought and also water shortage. It's seen from my previous colleague, he was mentioned about the main climate change factors on glacier and the water sources. That's why my research is more focusing here in this area. And also these two provinces are more the main base of the economy is based on the agricultural and the pasture sector. That's why our research is focusing in the western side of the Mongolia. Yes, this research is using the general framework of the geo-visualization approaches and participatory approach. But in this research, we are using the pastoral vulnerability assessment, vulnerability impact assessment, and policy assessment, and also made some adaptation strategies. And this research is more focused on the sub-province, province level, and try to the regional level. Yes, these are the main, some of the methods we are using in this research. For example, here is the main factors or main indicators to use it in this research is from the climate change or climate issue. We are using the drought exposure and vegetation indexes. And also from the human side, we use the pasture use or the pasture carrying capacity indexes. Yes. And each of the indicators, we use the different methods. And finally, we combine the old methods. This one is the some of the use of statistical data, because our research is not only using the geospatial analysis, but also using the some of the correlation analysis, how a pastoral system impacting the social and economy of the region. That's why we use the several social and economical statistics. This is some of the remote sensing and meteorological data sources which we use it in this research. Okay, here is the some of the results how climate change impacting the pasture vulnerability. For example, in one of the province in this map, you can see the dark blue colors, which shows the highest vulnerable, pastoral vulnerable areas. And the volume graphs are showing the several indicators which used for the pastoral vulnerability. For example, the dark color colored area had the highest eviction from the three of indicators. But in this province, the most effective variable is drought, which means relating from the climate change. And second one is the pasture use, is more relating from livestock related issue, for example, the growing number of the livestock, and also some pasture managements, grazing managements. And this, based on this map and the analysis, we are evaluating the level of the vulnerability on livestock, human, and pasture. For example, in this table, we can see the most vulnerable and low vulnerable parts. For example, here the 15% of the people, 20% of the livestock, and 12% of the pasture area are in the very high vulnerability area, which means they should be the local policymakers should be considering this part. This is also same as the previous result, but in this province, the human-related activities are main driving forces, which means the overgrazing is what grazing is increased related to the number of livestock, and also shortage of the water sources and ineffective pasture managements. They should be considering this issue. But in this province also the vulnerability level is very high for human and also livestock and pasture areas. That's why this province should be more considered than another province. This shows about the climate change impacts on livestock, how it is affecting livestock. For example, this graph shows about the livestock loss, miscarriage percentage, growth rate of the livestock number, and pasture vulnerabilities. You see from here the yellow color shows about growth rate of the livestock, and the purple line shows about the pasture vulnerability. When pasture vulnerability is increasing, that the number of livestock loss and also percentage of miscarriage of livestock is increasing. Oppositely, the growth of the livestock number is decreasing, which means there is have the very big relationship between the climate change and the livestock livestock growth. Yeah. Then the next slide is showing about the climate change impacts on the population changes. For example, the provinces which has the high pastoral vulnerability, their population is changing much. For example, from this map, you can see the changing volumes of the population between this period is high in this high volume of the pastoral vulnerable areas. That means like when the pastoral vulnerability is high, that the countries or the local areas people, they have the changes to move in the other area or they move to the another the areas which can hunting the jobs or the economics to developing. That's why we can concluding that the pastoral vulnerability and the climate change is affecting the population changes or the migration in the country. The another issue is very interesting is we try to concluding how climate change affecting the social issues of the local areas. For example, here you can see the impact on the life expectancy. This graph that shows about the life expectancy related with the pastoral vulnerability. When pastoral vulnerabilities become higher, the life expectancy is become no difference or they're not increasing. Or when the life, when pastoral vulnerability is become down, the life expectancy is increasing. This can say the very good, maybe good relationship between the life expectancy. The life expectancy is highly correlating from the climate change related pastoral vulnerability because of their differences. For example, like differences of the life expectancy between men and women is very high in two provinces. For example, in the first graph, the life expectancy of the men in 2018 is about 65, but the women are 74, which means like 9 years difference. That is affecting too much, I think. And also in the another province, for example, in 2018, the men's are 69, but women's are 75. Which means the men are more affected by the pastoral activities or the climate change tied to their working conditions in the harsh climate and also limited services provided by the social systems. This is the main considerable issue from our research. Maybe then based on this research results, we made some of adaptation options in these two provinces. That is very useful to the local policymakers, how they should consider these issues in the future policy making and the climate change adaptation policies. We provided these all options to them. Yes, then finally, I would like to conclude in this research. Based on this research, we can contribute some suitable adaptation options to local policymakers, and also we start need to establish a faster degradation inventory and monitoring system for the future prevention and measurable database, to collaborating with the other countries and also in the region. And also we need to improve the health services for hurting communities, taking into consideration men's living and working conditions for their life expectancy. And we need to establish the herders' capacity development system through the adaptive technologies and information. And we need to develop the adaptation policies in the region, which can integrate in the sustainable development and the climate change mitigations. And finally, during this talks, we can conclude to extend in our research in the national level, and if possible, is in the BR region. And also we need to increasing establishing the future international collaborative research groups on climate change and sustainability in the region. And I would like to end in my presentation. Thank you very much.
Thank you very much, Professor Sudansacek. So, dear colleagues, we arrived to the conclusion of the presentation for today's session. We are slightly out of time. To be more precise, we are 35 minutes out of time. So we talk a little bit too much sometimes. So first, if you have the people who are watching us on YouTube, please type the questions if you have, and we shall distribute them among the speakers today. For those people who are in Zoom, so Zoom participants, please, if you have questions, please raise your hand or just make somehow to be known on the monitor. So I see you all on the monitor now, and I don't see who is raising his hand. Okay. Probably I have questions. 1, 2, 3. Finished. So no questions online. So as to inform you, first of all, we will put the presentations on the special site of Russian Academy of Sciences, which is RAS, is Russian Academy of Science International. So one word, rusinternational.org. So all the presentation can be seen there. Also, we'll discuss with the ANSO organizers that probably the presentations will be on the site of ANSO. So everybody will have a possibility to look at the slides presented today more carefully. So once again, I would like to thank all the participants for these interesting talks and presentations. And I think that we have covered very wide selection of topics on climate change in hot spot areas. And I'm pleased to see the level of interest to this topic was generated by the people, because few thousand people have been watching us using YouTube. I will not talk general words about the importance of this discipline, because of course everybody understands that global warming and climate change is probably the most principal problems which we have. The mankind has to solve somehow these problems. So I will not talk too much about these challenges. And to finish, I would like to remind the audience and everyone presented here today that tomorrow will be a second day of the event, and the topic will be also impact of climate change and its solutions. So everybody is welcome to participate. I hope that it will be also the same interest as today. It will be interesting to continue our discussion and to learn a lot about this very important subject. Well, thank you very much, and I wish you a good day. And there are some questions I see, for example, cooperation through ANSO and others. Well, to all of us? Cooperation through ANSO and others. What does it mean?
I think that we can cooperate in the same version through ANSO and through Russian Academy of Sciences. We can organize supporting for cooperation between our scientists.
Sure. The best way is to use the sites which we have, rasinternational.org, our site of ANSO, and to continue the discussion. So thank you very much again, and I wish you a good day. It's already evening in China, so I don't know what is in Chinese. Ciao, bye-bye, cheers, 谢谢. Thank you very much, and everybody, merci beaucoup, dankeschön. Köszönöm szépen mindenkinek. Everybody, thank you very much. До свидания.